Hello and welcome back to the video lecture series on statistics for machine learning. We are going through the inferential statistics concepts, and at the moment we are going through the sampling theory, right? So sampling theory, we have talked about it already. Now we're going to talk about estimation of parameters. Okay, so before we get into estimation of parameters, we need to note a few terminologies related to estimation of parameters. First of all, when we talk about parameters, what does it mean? What is a parameter? So whenever I think in context of a whole population, right? I have a population, and whenever I talk about the different statistical measures in context of the population, say for example, the population mean, okay, or the population, say, standard deviation, okay. So those are the parameters. So mean is generally resembled by the symbol mu. The standard deviation is generally resembled by the symbol sigma and all those stuff. Okay. Uh, Now the same thing when I go for the sample. Okay, I measure it for the sample. The same thing that is known as statistic instead of parameter. So here I call it a parameter, param, and here I call it a statistic. Okay, so what I try to do is basically use a statistic to estimate a parameter. Okay, so what is the statistic? Say for example, I can think of a sample mean as a statistic. Sample mean as a statistic. Okay, or I can also think about a sample standard deviation as a statistic, right? So those are the different statistic in case of in case of a sample. Okay. Now, just let me mention here, this is generally resembled by x bar. So here it is mu for the parameter, here it is x bar. And here it is sigma, and here it is generally resembled as small s. Okay, so these are the, what should I say, the notations, right? Now, one important concept is the sampling distribution. This is a very important concept that we all need to understand, the sampling distribution. What is a sampling distribution? In a very layman's term, if we try to understand, we have already seen the probability distribution, right? So the probability distribution in case of a sample statistic is known as a sampling distribution. Okay, so let's look at an example so that we can very well understand what it is. So let's look at a population. Say I have a population, say 2, 6, 10, 14. These are the 4 units I have as a part of the population. And I draw samples of size 2. I am going to draw samples, different samples of size 2. Okay, and what I use here is simple random sampling without replacement. So once I pick it up, I will not give it back. So what are the possible samples in this case? So either I can use this 2,6 as a sample, okay, or I can use a 2,10 as a sample, or I can have a 2,14 as a sample, okay, 2,14 as a sample, or I can have a 6,10 as a sample, or I can have a 6,14 as a sample, okay, or I can have a 10,14 as a sample, right? So how many samples do I get? 10, 14, I'm sorry, 10, 14. So 1, 2, 3, 4, 5, 6, obviously 3C2, sorry, 4C2, 4C2 is what I have. So 6 samples I can get. Now I calculate, say for example, I'm trying to do the sampling distribution of the sample mean x bar. Okay, so what are the different sample means I can think here? Say for 2, 6, the sample mean is 4. 2 plus 6, 8 divided by 2, 4. This is going to be 6. 2 plus 14 is going to be 8. 6 plus 8, this is also going to be 8. This is going to be 10, right? And this is going to be 12, right? Now, if I put it here, so 4, 6, all both of these will come here, 8, 10, and 12. These are the, sorry, 12. These are the different values in the sampling distribution or the probability distribution. If now I have to calculate the probability. So how many total number of possibilities? 1, 2, 3, 4, 5. Total 5 possibilities, 5 different options of sample means. And the probability, if I calculate, so 1 by 5. This one is also going to be 1 by 5. This is going to be 2 by 5 because there are two favorable cases, 1 by 5 and 1 by 5. So this is going to mean to be my sampling distribution of sample mean. Sampling distribution of sample mean which is x bar. This is one very important concept that we need to understand, because based on this concept more such concepts are going to build. One small problem I think I have committed here. I basically the total number of possibilities is 6. So here the denominator needs to be 6. So all these are going to be 1 by 6, 1 by 6, 1 by 2 by 6, because there are two favorable outcomes. So total possible outcomes were 6. So that was one mistake I made. So 1 by 6, 1 by 6. Now if I just do a sum total, 1 plus 1, 2, plus 2, 4, plus 1, 5, plus 1, 6. So 6 by 6 is 1. So now this makes sense. So this was one small problem I made. Okay. Now next I need to find out how the parameters and the statistic are related. So for that there is one more very important theorem. Okay. So that theorem is called the central limit theorem. Okay. The central limit theorem. What does it say? Before I come to that, one more thing that I need to say is we have just seen the sampling distribution of a statistic. Here we have seen the sampling distribution of the sample mean. Now the standard deviation, if we calculate the standard deviation based on this sampling distribution, that standard deviation of this sampling distribution is called the standard error of the statistic. Standard error of the statistic. So here the standard error of x bar. Now here comes the central limit theorem. Central limit theorem says that if we draw a sample of a reasonably large size, and that reasonably large size is assumed to be greater than or equal to 30. So if the sample size is greater than or equal to 30, then in that case the population mean mu is equal to the sample mean, and the population standard deviation is equal to the standard error of the sampling distribution. Okay, so sigma is going to be the standard is equal to the standard error of x bar. This is by the central limit. However, there is one assumption being made, and that assumption is the sampling distribution. So here the sampling distribution of sample mean. So sampling distribution that follows a normal distribution. That is a normal distribution. That is the inherent assumption which is being made. So two things, that if the sample size is sizable, okay, is significant, so it is greater than or equal to 30, that is the number being assumed, and the sampling distribution is following a normal distribution. In that case, the population mean, which is the parameter, is equal to the sample mean, and the population standard deviation is equal to the standard error of the sampling distribution. Okay, so this is a very important theorem, and we can look at one or two simple problems which can be solved using this theorem. Okay, so we'll look at that. Stay tuned. Thank you very much.